Hello. In this video, I'm attempting to solve this KenKen puzzle. To be honest, I'm not an expert um, on these puzzles. Maybe this is my third or fourth one, but I think they're very um, interesting. And so I decided to solve one of these puzzles just on the go to see how it goes. So if you're not familiar with how these KenKen puzzles are working, the idea is that here we have a 5 by 5 grid, and in each of these grids, a number has to be placed between 1 and 5. So the numbers that we're using are 1, 2, 3, 4, and 5 in each of these squares. And we can repeat a number on any row or column. So each row and each column contains exactly the numbers 1, 2, 3, 4, 5 exactly once. All right, so, and then this 5 by 5 grid is divided into subregions. And each region, as you see, it has solid boundaries. Each region comes with a number and an operation. So this 1 and minus means that these two numbers, their difference, when you subtract them from each other, you get 1. So they could be 2 and 1, or 3 and 2, or 4 and 5 in here. And this block here, this 2 by 2 block, the numbers add up to 9. So 9 here means, when you add the plus here, means that you add them up, and the result will be 9. And same thing here, the product of these three numbers will be 40. The sum of these 4 is 9. Divide 4 means that these two numbers, one divided by the other is 4. So we can immediately say that these two numbers are 1 and 4. Now it could be 1 here and 4 here, or the other way, 4 here, 1 here. The sum of these three numbers is 10, and the product of these three numbers is 50. So we have to use that information. This is a puzzle, so we have to use the given information to fill in the numbers. All right, so as we noticed, these two numbers, one of them is 1 and one of them is 4, because if you look at numbers 1 through 5, the only way for two of them to satisfy the equation a divided by b equals 4 is that one is 4 and the other is 1. So we have possibilities though. Maybe this is 1 and this is 4, or maybe this is 4 and this is 1. So those two cases, let's just keep in mind. Another interesting thing here is that the sum of these three numbers in this block is 10. So that could have been happening in a variety of ways. It could have been for example, it could have been 5, 2, and 3, or 5, 1, and 4. But we can say that a 5 must appear, because if there's no 5 in this group, then the sum would have been at most 4, 3, and 2. And that's 9. It's not 10. So we must have one of these three numbers must be 5. Which one, we don't know, but one of them has to be 5, and the other two must add up to 5. And the other two then could have been either 2 and 3 or 1 and 4. Okay, so what's happening here? We have the product of 50. How could we have three of these numbers multiplied to 50? Well, 50 definitely needs a factor of 5. So again, one of these numbers will be 5. And the other two must multiply to 10. So the other two must also be, one of them must be 5 and one of them must be 2. So now we have two 5s here. And because they couldn't be on the same row or same column, that means that they are here and here. So this is 5, this is 5, and this is 2. And that's the only way you could have had a product of 50. Okay, remember that we said there should be a 5 in this group. Well, the 5 could not be here because there's a 5 here. It could not be here either, so it must happen to be in this row. So there's a 5 here. And the other two numbers are either 1 and 4 or 2 and 3. You have to wait for more information coming. All right, so now what else can be said? So here we have a product of 40 that needs a factor of 5. Because of this 5 here, we can't have that 5 here appearing in this row, so the 5 must be here. The other two numbers would be 2 and 4. Yeah, because that's the only way to make 40. 5 times 2 times 4. So 2 and 4 will be here. Which means that these two numbers that they were supposed to add up to 5, they are not 2 and 3. Because if there is a 2, so here I either have 2, 4 here, or I have 4, 2 here. Either way, these two squares, one of them is 2, so this can't be 2. This can't be 2. The same thing happens here. This can't be 2. So these numbers are 1 and 4. But again, they can't be 4 either. This can't be 4 because the 4 here and here. And so the 4 must appear to we must have the 4 here and 1 here. So again, these are either 4 and 2 or 2 and 4. And that leaves 3. The only possibility for 3 on this row must be over here. So that's 3. Okay, so in this block here, the sum is 9. We already know that 1 and 4 and 5 happen to belong to these 3 spaces. The remaining 2 and 3 must be here. So 2 or 3, 2 or 3. The sum of 2 and 3 is 5, which means that these two numbers add up to 4. This and this, they have to add up to 4 so that the total is 9. And the only way we could make a 4 here is 2 and 2 is not allowed, of course, and then you have to have 1 and 3. So these are 1 and 3. 1 or 3. Okay, something is not right. Well, why not? Because if these are 1 and 3, then they can't be 2 and 3. Oh, well, let's see. Why not 3 and 1? Yeah, okay. That is possible. Okay, so, sorry. So 1, so these two numbers are 1 and 3, which means that this can't be 1. That's 4 then. So this is 1. All right, so we're ready to fill in there. 1 and 4 go there. Which leaves us with 2 and 3 here. 2 and 3 here and here. Again, that's a sum of 5. That leaves us with 1 and 3 here. Okay, so what's next? The point in solving a KenKen puzzle is to be fast, but for me, more is to just get the logic. And it's really useful to take our time to understand what's going on. So, okay. I haven't used this information. The sum is 10. So I already have a 3. So this is 7 then. These three numbers add up to 7. Well, one more strategy to see where are the 5s. So we already realized, okay, this row has a 5, this row has a 5, 5, 5. That last row must contain a 5 as well. Okay, we already know it's not here. 5 cannot be here. Is it here or here? No, the reason is that, well, could it be? If one of these two was 5, let's say for a minute that this was 5, then 5 and 3 is 8, then these two must have been 1. This must have been 1. And this must have been 1. But that's not allowed because we know that these two numbers, one of them is 1, that will contradict. So this can't be 5. Well, what if 5 was here? No, it can't be 5 because there's a 5 here. So 5 can't be here. 5 must be here. And so this is 4 because the difference should be 1. If this is 4, this must be 2, this must be 4. Well, if that's 2, we know that these are 2 and 3. So if this is 2, this must be 3, this must be 2. So those numbers are 3 and 2. And so these are 1 and 3. In this column, we need a 1. We put it there. And if that's 1, this is 1. And this is 3. So this is 2 and this is 3. Remaining 2, remaining 4. 1 and 4, 5 and 2, 7 and 3, 10. All right, so let's move on to another puzzle here. This is another 5 by 5. So we know that these two numbers multiply by 20, multiply to give 20. The only way is 4 and 5. So 4 or 5, 4 or 5. These numbers add up to 6. That could have been 1 and 5 or 2 and 4. Can be 3 and 3. So these add up to 5. That could be 1 and 4. It can be 1 and 4 because we know that this unit has a 4 in it. So the only ways are 2 and 3. And that must be 1 then. This is 1. They add up to 9. So these two add up to 8. The possibilities are 3 and 5. And that's it because we don't have a 6. So 3 and 5. These are 3 and 5. Clearly they can be 4 and 4. These two numbers differ by 4. Differ by 4 can happen in one way. It's just 5 and 1. So these two numbers, one is 5, one is 1. But this can't be 5 because these are, one of them is 5. So this must be 1, this must be 5. So in this column, we already have a 1, a 3, and a 5. So these are 2 and 4. And clearly 2 times 4 is 8, so I need a 3, which means these are 1 and 3. And so these are 2 and 4, which makes sense because they have division should give you 2. So actually this information here is extra. They could have just not put anything here to make it a little harder. 2 and 4, so okay. The product here is 10. The product of 10 can happen only if we have 2 and 5. I think that does it because now we have a lot of information too. There's a 2 and a 5 here, so this cannot be 2 because there's a 2 here. Must be a 4. There's a 5 here, so this must be a 3. If this is a 3, that's a 5. If this is a 4, that's a 2. Right, so if this is a 2, then this must be a 3. If this is a 3, this must be a 2. All right, what's going on over here? The product is 16. The only way that you could have a product of 16, well, it could have been 4 times 4 times 1. Yeah, that's the only way because 16 has no other factors except 2 prime factors. So the only numbers that could appear here are 1, 2, and 4. Well, it could have been 2 times 2 times 4 as well. So there's a repetition. If 2 is repeated, well, we know that none of these could be 2 because there is a 2 here and there's a 2 here. So we can have a 2. That means the only ways are 4, 4, and 1. So 4, 4, 1. Remaining 3 in this column, in the row, there's only one left. It's 3. The sum is 8, that's a 3, so the sum is a 5 now. Could be the only way that you could make a 5 here would be, well, you could have 4 and 1 or 2 and 3. Can't be 4 because there's a 4 here and here, so none of these are 4. So they must be 2 and 3. The only way for that to work out is 3 here and 2 here. And therefore, that must be a 4. And that must be a 1. So this is a 3, and this is a 2. And if this is a 4, this is a 5. And that's a 4. And we're almost done here. We just need to fill in here. We need well, moreover, if this is a 2, then this is a 5. And this is a 2. And now we have to just fill in 1 here. And sorry, another 1. I have a 1 already. 1, 2, 3, 4, 5. 5 here and a 1 here. So here's a solution to this KenKen puzzle. Okay, the next one is 6 by 6. All right, look for some obvious things we can do. Well, 3, clearly, must be here. The product being 4 can happen either as 4 times 1 times 1, or 1 times 2 times 2. We have options here. The division is 2, so that's either 6 and 3, or 4 and 2, or 2 and 1. Many options. Same thing here. The difference 5 means is 6 and 1. There's no other option. So these are 1 and 6. The product being 20 means they're 4 and 5. And so the remaining 2 in this row are 2 and 3. The product being 48. Well, if this was a 2, then we need a 24 up there, which can be done as 4 times 6. That can work out. If this was a 3, then we need a 16. But 16 can't work out. 16 is 4 times 4. We can't have that. And we don't have any number bigger than, we don't have 8 times 2. So that means this cannot be 3. This must be 2. This is 2, so this is 3. And these are 4 and 6 to make the product work out. Well, if the division is 2, they're either 6 and 3, 4 and 2, or 2 and 1. But 4 and 6 are appearing in this block over here. So they must be 2 and 1. And so 3 and 5 must be in these two. 3 is here already, so I have a 3, there must be 5 here. Add is 17, so that's already 11. 11, we need a 6. All right, the product 16, maybe closer to the, oh, if this is 6, then this is 1. This is 1, this is 6. Okay, product 16. That could be either 4 times 4 times 1 or 2 times 2 times 4. But we already have 2 either here or here, so none of these are 2. So the only way for the 16 is 4, 4, and 1. Which means this cannot be 4. This is 5, and this is 4. Which means this is 6, and this is 4. And 1 and 2 here, this must be 2, this must be 1. All right, division is 2 in here, so it's either 6 and 3, 4 and 2, or 2 and 1. Well, 4 and 2 can be, 2 and 1 can be because of that. So 6 and 3, 3 is here, so this is 6, this is 3. Remaining is 2. Product is 4. So it's the only way for that to work out is 1 and 2. Left 5 and 3 for this. So it's 5 and 3. What's left here is 2 and 5. Well, this division is 2. 5 can't be here. So this must be 2, this must be 1, this must be 5. And that's either 4 or 6 because subtraction should give us 1. Can't be 4, must be 6. What's left is 1 and 3. 1 can't be here, 1 is here, 3 is here. The difference is 2. Where is next? The difference here is 2. So they could be, well, I mean, 4 and 6 are 6 can be here. So 6 is here, 4 is here. Remaining terms are 4 and 5. Well, actually, this column is almost done. We need a 5 here, 4 here, 1, 2, 3, 4, 5 here, and 2 here. All right, one more. Like these. I think these are really good for elementary school kids learning basic operations and also logic, because there's a lot of reasoning that goes into deciding what to fill in. So this is a 5 by 5. So we have a 2 already here. Division is 5. The only way for that to work out is 1 and 5. The product is 40. Product is 300. Okay, I have to review our multiplication table. All right, so 72. 72, 1, 2, 3, 4, 5 numbers. Well, 72 is 8 times 9, so 2, 2, 2, 3, 3, and 1. You could have had, yeah, that's the only way this could work out. And clearly, we need, or 4, right? So, because we cannot have 3 2s, no matter what you put 3 2s in here, there's going to be 2 of them in this row. But this could be 4 here. But we need 2 3s. That's the point. If we have 2 3s, and they can't be both on this column, so one of them must be. And 5 cannot be here at all, so 5 must be here. And these are just now 1, 2, 3, and 4. These numbers are 1, 2, 3, 4. Okay, what's next? 300. So this product is 60. We need another 5 because 300 divided by 5 is 60, which is still divisible by 5. That other 5 must be here. And these must be 3 and 4 to make 300. Three and 4. Oh, they can be. Well, 3 can't be, so this is 4, this is 3. These are 1 and 2. Can be 2 here, so 2 is here, 1 is here. Well, 1 plus 2 is 3. The sum here should be 10. These 3 numbers should add up to 10. There should be 3 and 4, I think. There's no... I have to wait. So these are 1 and 2. It can be 1 because one of these is 1. So this must be 2, this must be 1. The product here is 40. So the product here is 20. There's a 5 here, so it must be 5 and 4 here and 5 here to make 20. So this is 1, this is 5. Remaining 2. Okay, so that leaves, we said that these are 1, 2, 3, and 4. 2 can't be here, here, or here because of this, this, and this. So 2 must be here. My mouse is not working properly. So 2 must be here. And that leaves 1 and 3 and 4. Okay. These are 1 and 3. These are 3 and 4. Oh, well, then this is 5 because this column here needs a 5. It's not here, so it must be here. The sum is 12, so the other two have to add up to 7, and that's the only way 3 and 4. Well, 3 can't be here, so 3 must be here. And 4 must be here. So this is 4, this is 3. This is 1. Remaining 4, remaining 1. So that's 3. Great, so now, actually earlier today I attempted to make one of these KenKen puzzles. It turned out that the puzzle that I made did not have a unique solution. So one condition for the KenKen puzzle is that it has to have a unique solution. Nevertheless, I'm going to share it. And let me see if you guys can figure out how many solutions are there. I think I found 3. I found all 3 possible. Yeah, I think there are 3 solutions. Draw the boundaries as well. So this is one block. Is 11 plus here. This is 40 times. So the product of these 3 numbers is 40. This block here is 13 plus. This block here is 1 subtraction. This block here is 18 multiplication. This block here is 10 addition. And this final block here is 40 multiplication. So there are these are the blocks, and those are the operations and the numbers in them. So I got like, it was going very well until the end. At the end, there were just a permutation that could give me more than one solution. But it was fun up to that point. But then it turns out that there is no unique solution for the puzzle I made. All right. Thank you, and I'll see you later.